Welcome to AI for Good, the leading action-oriented, global and inclusive United Nations platform on AI. Organized by ITU, in partnership with 40 UN sister organizations, and co-convened with Switzerland. The goal of AI for Good is to identify practical applications of AI to advance the United Nations Sustainable Development Goals and scale those solutions for global impact. In today's session, we're counting on you to use the live video wall feature to ask questions and post comments to help create an engaging discussion. We encourage you to stay until the end to chat, connect, ask questions, and network with our distinguished panelists and world-class AI experts in the neural network. It is now time to kick off the session and welcome our first speaker. The floor is yours.
Hello everyone, and thank you for joining our session today. Welcome to our first problem statement we'll be introducing this year for the launch of the AI, ML and 5G Challenge 2023. My name is Miya Nishio with the ITU, the International Telecommunication Union, the United Nations Specialized Agency for Information and Communication Technologies. The Machine Learning 5G Challenge, now in its fourth year, aims to create a community to solve network-related problems and issues using machine learning. Registration for this problem statement we are introducing today is open from today and will close in August this year, with submission deadline being 18th of August. Please connect to the AI and 5G Challenge Slack channel or sign up to the email subscription to get updates on various webinars and workshop sessions that will be taking place this year. The challenge this year will be featuring a batch of new problem statements, all relevant to the updates and progresses we've seen in both artificial intelligence and communication networks. The title of today's session is Fault Impact Analysis for 5G using AI ML. We are counting on you, the participants, to help creating an engaging discussion. So if you have any questions, please type them in the video wall and we will take them during the Q&A session right after the talk. Without further ado, I would like to introduce today's main speaker, Antonio, who is currently a senior researcher with Huawei Technologies in Paris, France. He is the co-inventor of more than 25 patents and has authored over 80 research articles. His interests include heterogeneous wireless networks, machine learning for network modeling and optimization, and green communications. Today, we also have Dr. Shi with us, who is currently a technical expert with Huawei Technologies. Her research focuses on algorithm design for the modeling, analysis, resource management, and optimization of radio access networks. She's also experienced in transferring research progress into industrial practices. So over to you, Antonio.
Thank you, Mia. Welcome, everyone. I hope you find this challenge interesting, and as Mia said, don't hesitate to ask any question at the end of the presentation. So the challenges title is Fault Impact Analysis for 5G using AI and machine learning towards service-oriented network operation and maintenance. So as you have heard, I'm Antonio. I'm a senior researcher in Huawei Technology in Paris, France since 2020. Before I was a senior expert in CLAT.
Sorry, Antonio, just to quickly jump in. I can't see your presentation. I can see that you've started screen sharing, but I can't actually see your screen.
Okay, I'm sorry. Let me see what's going on then. Can you see my presentation?
No, I don't know whether Mia or Vishnu can, but I can't see it.
No, we can't see.
No.
Okay.
It did work fine. It did work before fine, but
okay.
I don't know what's happened.
Let me try again. Okay, let's try like that.
Yep.
Is it working now?
It's working, yeah. So
let me try if I move the slides. Does it move?
No, but you might need to go into presentation mode.
I am in presentation mode. Okay.
I can still see all the slides on the left.
Okay, let's try something else. I'm sorry about this. So, third screen, this. Can you see my slide?
I can, but yeah, there we go.
Does it move?
It does.
Can you see my?
I can. Perfect. Thanks, Antonio.
Great. Yes. So okay, let's restart. I was saying that I'm currently a senior researcher in Huawei technology in France, and before I was a senior expert in CLAT from 2012 2019. I got my PhD from University of Grenoble in France. And as Miya said, my main topic of research is data-driven modeling and optimization in 5G RAN. Okay. Just a quick overview on Huawei. For those who doesn't know, our company is a leading provider for ICT infrastructure and smart devices. We have 200,007 employees, and 55% of these employees are involved in R&D activities. Last year, Huawei got $92.4 billion USD total revenue and invested 25% of this revenue in R&D in 170 country and region, and they an organization for a fully connected intelligent world. So after saying that, here you have the outline of my presentation. First, I will start with a brief introduction on 5G. Then I will jump on the network fault management problem, discuss more in detail what is the challenge, what this challenge is about, detail the source data, and then finally the solution requirements. First of all, as you know, 5G availability is spreading across the world. In particular, North America, East Asia, and Middle East and European operators are offering currently established service. And the target is to get over half of mobile connection on 5G by 2030. What is 5G network and how this network is decomposed? First of all, we have the radio access network. Okay, this part of the network is the closest part to the user equipment, to the customer, which provide through radio links the data that we use to surf internet, make our calls, messages, etc. Then there is the core part of the network, a fixed side, which is in charge of several functionalities like authentication, gateways, charging, etc. And then we have the data centers, which are physical side that also operator infrastructure, like operation and business. So regarding network operation and maintenance, so these functionalities become more and more complex in 5G area. Okay, first of all, 5G is more complex network than the previous evolution of a communication system. Each site construction need more time and more labor. In fact, 5G use more frequency band, more resources, and has more than 30 different deployment scenario. Okay, from private network, indoor network, different outdoor scenario. So a very heterogeneous business, which new use case and services. Also, the network come with larger operational expenditure for operator. So power consumption is increased with respect to 4G because new base station has a larger bandwidth, they process a larger spectrum, they have a larger number of antennas, and can provide higher throughput. Also, this comes with many more parameters to optimize and to observe. From a network operation and maintenance perspective, this means more alarms. So why we need this processing, this operation and maintenance? First of all, there are different dimensions in which this operation control the network. First of all, we have radio link, which affect the reliability of the network due to the channel propagation, mobility, interference. We have resource depletion. So this can be related to radio, computational, or memory resources. As well, node impairment. So we can have failure at hardware or software. So as you can see here, we have, this is a base station site, a 5G site. We have radio resources managed in the AAU and computational and storage resources in the BBU. So what are the functions of this network fault management platform in 5G? So in this platform, you have fault monitoring, fault analysis, fault diagnosis, and fault repair processes. So these are fundamental functionalities which allow the network to operate in the proper way and to provide reliable services to the end users. But why we need this is because the network deal with many uncertainty, many stationary, non-stationary environments with radio propagation, user mobility, and traffic demand which vary in time and space. We have a very complex network, as we said before, with multiple type of site, so many different type of hardwares with different characteristics, operating on more than 20 bands, different user equipment, more than 100 type of terminals, and in particular, more than 4,000 parameters to be monitored and optimized. Also, as I said before, 5G comes with a large variety of application use cases, which has greatly increased with respect to the previous generation of the network. And this diversity comes with different requirements and different applications. Finally, other sort of fault external to the RAN nodes exist, which may impact the performance of the system. So in this very complex ecosystem, network fault management play an important role, as I explained. So, and our traditional fault management rely massively on manpower. So you have front office people who monitors a KPI and alarm. These people, their role is to verify whether the network is performing in a good way, in a proper way, and issue tickets when they observe anomalies. Okay, these tickets goes to the back office people who play the role of root cause analysis. So identify which is the issue behind a KPI fluctuation or an alarm. Okay, and after this stage, a field engineer is sent to the network to do the reparation. Okay, as you can imagine, there is a massive amount of data to observe, to monitor, and to analyze. Okay, and this makes all the process more complex. As you can see in this right picture, in 1 month, for only 8,000 sites, so let's say big city in China, you have more than 1 million alarm, which is a very big number, as you can imagine. And only a part of it is actually related to wireless fault. Okay, other fault has to be analyzed, understood, but actually there is a limited amount of opportunities to operate, to deal with this fault and with this alarm. Okay, so beyond this, the network is very complex. Different KPI are intercorrelated. They are dependent on each other, and this complexity lower the efficiency of the root cause analysis and the overall process. Due to this, we have redundant work order and larger mean time to repair an issue. Okay, so to have a system which is more efficient, more effective, we would like to go from a manual system to an autonomous, automatic system where human expertise is replaced by AI. So this is the final target in the next year for network fault management. So why this is necessary? First of all, from our perspective, in our vision, traditional approach cannot assess the fault impact to network KPI, key performance indicator. The current approach is to deal as fast as possible with fault and alarm. Okay, so this means that there is no diversification between different alarms, between different faults. And this constrains the effectiveness of the fault management resource. In one case, a network node failure may not affect the overall network performance. For instance, if there is a low traffic hours, okay? So if one base station shut down for some issue, coverage and capacity of the network may remain stable if the request is low. In other case, other fault may not limit the service access of the end user, but actually strongly deteriorate the quality of service. So this type of fault have to be differentiated and handled with different priority. So the approach for the next years to come is to go from fault analysis and detection to understanding the relation between the fault and the network performance and the user quality of service. So how to do this? In this challenge, we want to predict the impact of faults on the radio access network data rate, which is one of the most important KPI in the network. So which is the speed of the network, how fast the user can receive the required data. And this would allow to better guide fault management and optimally allocate the limited operation and maintenance resources. Eventually, this will drive the network operation and maintenance transformation from equipment-centric to service-centric. Okay, so in this challenge, what are the inputs? So we collected input from real network data, and we have time series of node historical KPIs. We have fault duration and distance between the source of the fault and the network node in which the KPIs are evaluated. And we have a KPI knowledge graph. So I will describe all this in more detail in the following slide. I guess it will be more clear. And again, the output is understand the status of the data rate change due to the fault appearance for each network node for which the data is provided. So let's go to the source data. Okay, as I said before, we have data set from the radio access network KPI originating in multiple nodes. In particular, we have over 100 5G and 4G network nodes. Okay, for each of these nodes, the dataset, the provided dataset includes hourly KPI, which are provided as time series. Okay, in particular, each row in the time series include the network node ID, 7 run KPI, the duration of the fault in the network, and the distance of the network node to the fault in an hourly basis. So let's look at each of these elements in detail. Okay, as I said before, the first value provided in the data set for each node is the network node ID. Okay, then we'll give you the hourly timestamp. After that, there will be a column describing the access rate for that hour for that node, where this parameter measure whether service requests by each user can be accessed in the proper condition. Then there will be another value which describes the resource utilization rate, which measures the fraction of available resources used to provide services to the user. Another important parameter is time in advance. This parameter is related to the distance between the user equipment and the network node, and it ensures synchronization between uplink and downlink transmission. Why this is important is because users which are closer to the base station are characterized by shorter distance, which means that the signal received come faster to the user, while a user at the edge of the base station, distant from the base station, receive the signal after the first user. So these two users, however, they have to transmit their data in the uplink in a way that the base station receive their uplink data synchronously. So the user which is closer will require to have an offset, will transmit later with respect to the further user. So this offset is the time in advance. Also, we provide block error rate. which denote the rate of lost data due to channel interference, mobility, etc. Another parameter which is important with respect to the quality of the channel is the channel quality indicator. Okay. Also, this parameter provides an indication to the base station on the quality of the channel between the base station and the user. Modulation coding scheme denote the amount of bit transmitted by the base station per unity of time and frequency resources. And the data rate, which is the final KPI, denotes the amount of bit successfully received per second. Here on the right side, we provide you a data rate knowledge graph, which can be used to understand the relation between the 7 KPIs when the fault occurs. Okay, so an arrows means that when the fault occurs, there is a relation between the edge and the other edge. So the fault affects the resource utilization rate, and the resource utilization rate affects the data rate, and so on. Fault affects the CQI, and CQI together with timing advance affect the blur. And the blur with the MCS affect the data rate, and so on. As you can see, all of these KPI, all of them affect the data rate together. Okay. Regarding the fault, as I said before, we provide you the fault duration in seconds during the hour, as well the distance of the network where the fault originated to the network where the KPI are measured. So in the data set, 0 means there is no fault during the observed hour. 1 means that we are looking at the node where the fault originates. A value lower than 1 means that the fault does not originate in that node that we are observing, but there is a connection between these two nodes. So the fault in one node actually impacts the performance in a second node. And larger this value, it means that there is a higher agency between the two nodes. So what we expect from you? So what we would like is, first of all, to submit a report explaining your solution. So this report will include the outcome of your analysis, so results and accuracy, that you have to provide on a given test set. Okay. In the data set that we give you, there will be K-star CSV files. Each file corresponds to a node under a certain fault occurrence. So in each file, you will see that at the certain moment, there will be a fault appearing in the last column of the data. Okay. And you will have to predict whether this fault affects or not the data rate by predicting the status of the data rate change for the node under observation. So this status of the data rate measure whether the appearance is less. So let me explain you this better. In this example on the top, you see that for this network node ID at 6 p.m., there is a fault appearing, and this fault lasts more than 2,000 seconds. The relation in ones, it means that actually the fault is originated in this node, and you can observe that the data rate decreases from a value of 38 megabit per second to 0. This means that the status of the data rate change that has to be predicted is 1. In the second case, you can see that actually the data rate does not decrease. It actually increases because of the traffic demand fluctuation that I explained to you before. So in this case, the status of the data rate change to be predicted is 0. This means that although the relation is pretty large between the node where the fault appears and the node where we are observing the data rate, the fault duration is relatively small, and it does not impact much the data rate. Or maybe it's a fault which is not directly related to the data rate itself. So these are all these stochasticity that I described in the challenges. So how to evaluate your model, the quality of the solution that you provide? We ask you to use the F1 score, which is a combination of precision and recall. So the equation describing the F1 score is provided here on the right side of the slide. So let us denote as TP and FP the number of true positive results and false positive results. So using TP and FP, we can compute the precision as the ratio between the true positive and the overall number of test samples. So TP plus FP. And as a recall, as the ratio between the false positive and the overall number of samples. So you compute the precision, you compute the recall, and then you use both of them to compute the F1 score. So finally, as Miya said before, the registration are already open today and closed the 11th of August. The computation phase is between today and the 18th of August, and the 18th of August is actually the submission deadline for your project. So as a prizes, we have internship opportunity in Huawei Research Center in Paris, cash prize, and ITU certificate. So with this, I end my presentation. You can find here some related references, and I'm happy to reply to any of your questions. And hopefully you can participate in a high number and provide us a very good model for this challenge.
Thank you very much, Antonio. That's a very nice introduction to the problem statement. I agree with you. It's a very exciting opportunity for our members as well as the students and industry. So thank you so much. First of all, thank you for Antonio and she. It has been quite a bit of effort from their side to curate the problem statement and data. So thank you for doing that. First question. So is it label data? Do you have labels?
Yeah, the data is already labeled.
Very good. How big is the data?
Sorry, Vishnu, can you repeat, please, the question?
How big is the data? How big is the data?
As I said before, there is around 100 files, more than 100 files. Each of them correspond to a base station, and overall there are around 120 megabits of data.
Cool, that's nice. Thank you very much. The type of data. So one question which we always get is whether it is real data, simulated data, test bed data, and so on. So I want to ask you, how did you collect this data?
So we have a collaboration with Hong Kong Telecom, HKT. So they actually provided the data from a real network, as I said before, 4G and 5G network. This is not test data or simulated data. This data is collected in the network, aggregated with the hourly basis, and then we have processed it to provide data which is labeled and easily understandable for all the participants to this competition.
Absolutely, yes. Thank you so much. We always get this question also, where we can get the real data. Thank you for working with the operator to provide this data. I want to ask a slightly different type of question. Is there mobility in your test scenario? So when you collect the data, did you have mobility at all? I mean, you talked about timing advance. That reminded me of this question. You talked about distance propagation, but do you have mobility scenarios also as part of your data collection?
Yes, definitely. So since data is from a real network, user moves through the network. There are going to be these base stations are serving outdoor user, indoor user. So these user go from one base station to another base station, goes outside of the network, connect and disconnect. So each of these users in each of the base station will observe different environment, different type of traffic. So that's why from an hour to another hour, the actual resource usage change, the data rate change, because the number of users change, the requests that each of these users are pushing to the network, they are different, and this makes all the problem more complex. Obviously, there is the data rate change not only because of the fault, it's not static through time, but actually because of mobility, because of new user coming and going. And obviously during the night you will see maybe you can see smaller data rate because there are less user, or in some base station maybe there you can see actually higher data rate because there will be some user which are requiring very high speed services, and there are very few users maybe at that hour of the night. So the actual data rate will be very, very high because they can enjoy very high speed, being the load of the network very, very low during the night. And maybe during the day, it's the other way around. The resource usage is very high because there will be a large number of users. All these KPI are interconnected and make the problem more challenging.
True. Yeah. I think this is a very exciting information that you told, that there is a large amount of variation in the data that makes it even more interesting.
And stochasticity, it's the variation and stochasticity. It's a lot high randomness, I would say.
Yeah, it is understandable. I am guessing that you are using mostly bandwidth hungry applications. Am I correct? For example, you may be using video applications, or maybe downloading streaming type applications or something like that. Because your primary, yeah, go ahead.
No, please end your question.
Because your data says data rate, the impacts to the data rate. That's why I'm asking. So yeah, yes. What do you have? Do you have other types of data? I mean, other types of applications like low latency applications or some other types of services, or is it mostly bandwidth oriented services that you collect?
So yes, again, this is not test data, so we don't control the application or the services provided to the user. So there is a mix of application actually running through the network during the hours in which we have collected the data. So this means that there will be people making phone calls, which are very low demanding in terms of data rate, while a bit more demanding in terms of latency related jitter, etc. And maybe there are people doing gaming or video streaming. This depends also if the node is a 4G node or 5G node. You know that 5G as new application, people are using more and more 5G for gaming, for instance. So gaming is very, very challenging in terms of both data rate, latency, jitter, and so on. So there is a mix of this, and all this mix contribute to this variation of the traffic and different requirements, which make the whole problem interesting and very challenging.
True. Yeah, I think this is similar to what you mentioned earlier about different other factors, mobility, number of users. I think this is adds another dimension to the data. It's quite interesting as well. I want to ask about validation data. So, do you have separate validation data, or do you release other data later? or is this the full data that you have released? So the reason I'm asking, in case the models are submitted, when you evaluate, do you use another data, or is it the same data that you have published now?
Yeah, we will use validation data, which is not available for the competition, let's say, to test the model provided by the participants.
Cool. Yes, thank you so much. I want to ask about the knowledge graph. So yeah, that's, I think, in our previous discussions also, it was quite interesting that you have the knowledge graph. In fact, actually, many of our participants may not be from this background. So it helps them. It helps them that you have the knowledge graph. Why did you decide to introduce this? Because you can actually do feature relationships. You can actually use many type of other techniques to derive the relationships as well. But you have it. You have the knowledge graph. Why did you decide to put it?
We thought that this would be important for the participant of competition in the case they do not have the knowledge about the wireless system. I think, let's say, I mean, machine learning is not about only running a cool model and make them do all the work. Though we live in months in which ChatGPT and similar applications are becoming very popular, I think that expertise of engineer is very important. Feature analysis is very important. So this was our way to support the participant in the challenge to understand what are the relation between the different KPIs and maybe exploit this relation to build a better model.
Yeah, thank you so much. I as I told you, I think personally, I think that it is very helpful. It helps the non-communication background students and professionals to actually utilize the data. There is some data, some fields which are faster changing than the others. For example, MCS, Blair, which you have, it changes very much frequently than the others. It maybe in the sequence of milliseconds, it changes rapidly than the others. Other columns that you have. For example, fault duration comes in seconds, and MCS and Blair comes in different time scale. How do you handle this? I mean, you have it in the same data set, but you have different time scales for MCS, Blair, and
let's say that
fault duration.
the time scale is the hour, okay, for each row of our data set. This means that we are for like fault duration is the aggregated value of the fault duration in the hour. So the maximum value is 3,600 seconds. For the KPI is rather an average value of KPI. So collected through the different user which are requiring service through the node. So you will have an average value of MCS, an average value of the data rate, an average value of the timing advance offset, and so on. Yes.
Nice.
It's very good question. Yeah. Thank you.
Yeah, it's quite interesting. Yeah. I want to ask about future. So right now you have looked at at least the data which you're having on table is about data rate. So you have if we look at that service, which is impacted by the data rate. But one could also think of other type of faults which impacts other types of services other than data rate also. For example, a jitter or latency or something like that. So in future, what are you going to do next? I mean, maybe next year, next year when we have this webinar, what kind of data are you looking at? What is your research pointing towards? I mean, apart from this challenge and problem statement, there is a background behind your team's research, I'm sure. So in that context, where do you see this problem going? Are you looking at other types of services, other types of faults? Like, if not, what are your future plans in general?
Yeah, thank you for this question. So as you mentioned, there are many different open challenges in this domain. First of all, as you said, so let's think about the data rate. So now the first challenge is to understand whether the data rate is affected or not for each node. Maybe the second step is actually predict the data rate value, which is much more complex than this first challenge, which is already pretty challenging. And then we could focus on different KPIs. We would like to look at the coverage, at the latency. So having a full spectrum of model which are able to characterize how the network performance are impacted by the different faults which may appear would allow us to have a full pipeline, a full framework, a great solution to provide optimization to our customers.
Fantastic. Yes, yeah, I think that covers my answer. That full you mentioned about full pipeline and full framework, which includes a spectrum of models. I believe if some of these participants who are here listening to you contributes to that spectrum of models, starting with this challenge, I believe that's a great opportunity for our participants here. Prizes. So we always come back to prizes. I want to ask, you mentioned internships with Huawei. I mean, I would not pass that on. I think there are many students and participants here who would not pass it on. It's a very good opportunity for students and professionals. In addition, ITU, as you know, we as the last we have our own prizes and certificates which will come your way. We will put that on table also. You can watch our space to get that details. Can I ask you, Antonio and Shi, the papers? So yours is a research team. I'm sure you are coming out with papers. Do our participants, so let's say somebody comes up with a good solution, you think it's nice, it falls into this futuristic spectrum of work that you're doing, would you consider co-authoring papers with these participants, please?
Definitely. This could be one of the goal of the internship, Vishnu. So I mean, personally, I love to write paper, disseminate the community our great results. As I expect that we come up with very interesting model, great performance from our participant related to this challenge, I would very happy to help the participant, the winners, to come up with a very nice paper to be submitted to one of the flagship conference in our domain.
Thank you so much. That's wonderful news. You know, in the past, we have published the papers in ITU journal for future and evolving technologies. But of course, it's up to you. You can publish it in flagship conferences, journals. It's a great opportunity for our participants to co-author papers along with you. Thank you so much for that opportunity on behalf of our participants. Jia is asking the definition of fault. Are faults manually injected? Could you explain how the faults are in fact produced in the data?
Yes. So definition of fault. Fault is I understand is a very generic term which can be related to different let's say different events in the network, which can be related to maybe electrical power, can be related to simply software and hardware issue, lack of temporary resources because there is an overload into the network, or maybe too much mobility, something which is not expected, like people gathering in a location where usually there is no many people. Maybe there is a concert or some strike, some protest, something, anything, and so the network become to underperform, and this is an issue. And actually, the fault are not manually injected. Everything is real here from a real networks. So we have collected data from a real network, collaborating with an operator, and so there is no injection of fault into the node to decrease voluntarily their performance. So we want the node to perform as good as possible all the time.
Thank you so much. Let me see if there are Gaurav is asking the data set. So data set, Gaurav, let me find out where it is, and we will in our page we will add the data set details also. No worries there. It is it will be publicly available if not already there. So we will check that. Thanks, Gaurav. Is there I don't see any other questions. Let me maybe one last question on the data set. It's the scoring process. Scoring. Do you also look at what kind of submissions are required? Like, do you expect models to be submitted? Do you expect the code or notebooks to be submitted? Do you expect reports? What are you looking for to score, or presentations? Now, of course, from our perspective, ITU, as we did last year, if you come to the top of the competition, we have a challenge finale where you present. Of course, that's there. But apart from that, for scoring for this problem statement, Antonio, what should the participant submit to win the challenge? You can also say how to win this challenge. So how to win this problem statement? What are you? Yeah, go ahead.
Yeah, I think clarity and readability is a key issue. So we expect, as you were saying, a notebook where this, the model proposed read the data and run and come out with the results. And we expect a small report where your solution is described. Okay. regarding the metric, as I said, we would like competitioner to use the F1 score, which we think it's an appropriate metric for this kind of problem. And yes, I mean, in your report, try to be for sure make it as much as readable as possible, but do not hesitate to include maybe pictures or your analysis, and even if you have ideas for future works, something that you would like to do in the internship. And I mean, everything like this is all very well accepted from our side.
Thank you so much. That's quite exciting. I think these are secret tips. I hope our participants are listening. Thank you so much, Antonio, for those secret tips. I think it's quite exciting that you are open to feedback and ideas on future, as well as what kind of extensions can be done during internships. I think that's very rare. Thank you so much for that opportunity. I believe that with that we don't have any more questions. Thank you so much for patiently answering all the questions. We have registrations open, and the page is there. I would request everybody to take advantage of Antonio's and Chi's work. Thank you. Back to you, Miya.
Just very quickly, Vishnu, sorry, we have one question that's just come in. I'm just putting it into the chat.
Cool. Yes, we have time. Garima is here. Thanks, Garima. Thank you for the presentation. Is the data 4G or 5G? Do we need to consider only graph provided, or can we extend the? Excellent question. Yes. So yeah, I was looking at the lack of knowledge, but there are of course people like Garima who has more knowledge. So yeah, so there is domain experts. There is domain experts also. So can they add their knowledge? As is a good question, and whether it is 5G or 4G. Yeah.
Yes. So regarding the knowledge, or I mean, any extension to the provided graph, obviously we are open to any solution. As I said, if the participant come up with interesting solution that extend our baseline, this is more than welcome. It would be very exciting. And regarding to the network, this is a real network where 5G base station and 4G base station, they coexist with each other in the same location, in the same area. So it's both 4G and 5G base station that are providing the data set. Yes, I see new question coming. I don't know, Vishnu, if you wanna, maybe you can read them for the audience before I answer.
Yeah, sure. Yeah, I think Gaurav, thanks. He's asking, can you author papers, co-author papers without internships? I mean, yeah, go ahead, Antonio.
Yeah, I definitely. I mean, I understand that for some participant, internship is not a possibility. Maybe there are some other type of collaboration that we can set up. But if you come up with a very good proposal, or you win the competition, for sure we can come up with a paper together and try to publish these results. No problem. So I see another question. Is there any city in China fully running on 5G at this very time? I mean, as I show in the presentation, 5G is spreading through the world, and Asia is one of the locations where 5G development is going on very fast. Yes, we have 5G here in China. I'm actually in China these days, so I can tell you, you have 5G services here.
Cool. Thank you so much. Yes. I just want to go back and tell Garima that the graph, if you extend, maybe you can put it as part of the report or notebooks or whatever. So then it's easy for Antonio to evaluate what you are doing and what's the difference between the graph and which you are proposing, extending, whatever, in addition to what Antonio has. Thank you so much. Yes, I believe that's all. Again, thank you, Antonio, for patiently listening to all the questions and responding to all of them. And it is a great pleasure talking to you. It's a great opportunity as well. We will have further sessions later. We will trouble you again. So yeah, thank you so much, and back to you, Miya.
Thank you very much, Vishnu, and thank you everyone for participating.
Thank you everyone for sparing your valuable time to join today's session. I would like to especially thank Antonio for explaining today's problem statement. Very clear and very easy to understand. Please note the challenge is open for today for this problem statement and this problem statement only. The link for registration is already posted in the video wall, so if you are interested, you can start working on your solutions and submit the results on the portal. As Vishnu has also mentioned, we have more sessions planned in the near future, so please keep checking the AI for Good program page for details. You can also interact with us and other participants on the Challenge Slack channel. We are looking forward to your participation in the 2023 edition of the ITU AI ML and 5G Challenge. Again, thank you very much for joining and have a lovely day.
Thank you for participating in today's AI for Good session. We hope you've learned something new, innovative, and engaging in today's event. We now encourage you to continue the conversation on the live video wall in the neural network. Here you can ask questions, like and comment, share links, complete the poll, connect with interesting profiles, or speak one-on-one using the chat and video function. We invite you to explore the lobby, try the smart matching quiz, visit the virtual exhibits, poster boards, the eShop, and build your personalized AI for Good program. Let's shape the future of AI for Good.
AI is a powerful tool.
This summit can help ensure that artificial intelligence charts a course that benefits humanity and bolsters our shared values.